So let's go. Actually, we'll start. We'll start off with introducing myself. I'm Vignesh. I'm an Android developer. It's a beautiful evening, actually. Good evening, everyone. And I guess it's been a long day. So I'm going to talk about Kotlin Internal DSL. Well, in other words, I'm just going to, you know, try to have as much fun with Kotlin as possible in the next 30, 40 minutes. Well, this is just some kind of an expressive language construct that I have here, and I hope that by the end of session, everyone can just play around with and create a much better version than what I've done here. So let's go. So before starting off, I'll just tell you what this is going to be about. I'm just going to start off with a problem that I came across, for which this DSL presented itself as a solution, and then start off with what a DSL is, what are the characteristics to start off with, and what Kotlin has in store for us, and we'll start off with some starter Kotlin features, make it as simple as possible, and then we'll just start building something right here using whatever we've learned in like that amount of time. So it's going to involve a lot of switching back and forth between the IDE, not much of slides here. So we'll just be doing something, and in the middle, I'll just tell you guys as to what people are really using it for, where are they heading towards, and some common libraries that you guys have surely know about and stuff like that. Okay, so let's go again. To start off with, I wanted to show you guys the problem that I came across. You see a data class here, and I just have like 10 variables. Except that in my case, it wasn't like just 10 objects. It was around 20 to 30. I was just building some sort of a heterogeneous list view. It had like 4 to 5 item types, and there were a lot of scenarios, a lot of use cases, but I'll just mention a few to start with a few. These all these items, all these list items had a lot of states in common, and it was and for all these kind of list items, it was okay if some of these objects had their default values or null variables or whatever, and also there was some sort of a mini logic to compute the values of all these objects. For example, string 1 had a logic. There was a logic based on which string 1 was computed. Okay, so I was just getting onboarded with Kotlin, so it was so messy when it was like a huge constructor, and I had to kind of I didn't really like it, even though I was very new to Kotlin, and well, there were a lot of solutions actually, but one thing which attracted me was the ability to create some sort of a different language construct here. So it's just some name here and just a block of code I have, and I just have to specify whatever I want for that particular data class object. It's just a configurational language construct that I have here. So that's basically when I came across this saying wherein you are going to use a DSL, or you're going to create a DSL for used by your developers. I mean, I see DSL more like as a developer to developer service here. Okay, so it's just us making life easy for one among us. Okay, so this is more like if a developer is going to just configure, and he need not know the internal implementation, which is similar to my case, wherein a developer just has to specify what variables he needs. For example, I just need string 1 or string 2 with respect to that example I just showed, right? And the UI would be painted accordingly. So it was all quite all right, and this was a perfect solution as far as I was concerned. And well, that's how it all happened, and that's how I started exploring as to what else Kotlin has in store for me. So yeah, that is about it. And if we have time, I'll actually run you guys through the language construct that I had just shown to you guys before, right? So let's start over. Let's start off with the very basic concepts. As far as we're concerned, we can, looking broadly into these languages, we can safely categorize them into general purpose and domain specific, right? You look at Java, and for example, we look at Java, we know like it's used quite extensively, and that in itself is a very good definition of a general purpose language. That is all there is to it. And talking about domain specific languages, I think any of you would be able to make the definition out of it. It's just specific to a domain. But the point here is what can a domain be? And that again depends on your perspective. That again depends on the problem you want to solve. Like if you ask me, a domain could be a feature, a domain could be a subset of a feature, a domain could be a system. But then we'll have to keep in mind some characteristics of DSLs when we are targeting a domain here. Okay, so essentially, we are exposing very easy APIs for others, for our colleagues, for developers, for the community here. Okay, we're just making life easy for them to configure our domain. Okay, so we should abstract a lot of things. They should not know a lot of things, because of which life is easy for them. And talking about English, they just have to skim through the code just like any other. That should not even feel like a code for them, and that is what we should consider, rather than what I mean. Yes, of course, there is some sort of a domain that we are targeting, but on top of that, these are the factors that I think we should give a very careful consideration when we are building some sort of our own language, some sort of a domain-specific language here. Okay, so so talking about characteristics, right? I wanted to show you one thing which we've seen all our life actually, and which is this. And so when I started off Android, I think for a good amount of time, I did not even need to know what this internally is. And that is the purpose of a domain-specific language here. So this is just configuration. This is plain configuration that we have here, right? So let's take this min SDK version, for example. So this reflects one very important characteristic of a domain-specific language. See, that line knows about someone external to it. For example, it knows who it has to set that min SDK version to. It's not like we have explicitly specified that. For example, app.set min SDK version. No, we haven't done that. We just specified it in a line, and that knows what to do. It has some external context. It has some information external to it, and that is a very important characteristic of a DSL. So you know what it does to you when every single line knows about someone external to it, you tend to specify less code. That is what I mean by noise here. So when those clients, they know a lot of information, they don't need you to specify that information to them, and that's what the context is all about. That helps you specify very short, clear and concise language construct. Okay, and talking about fluency, that's pretty straightforward here. You just skim through the language. You just read through it like you read some sort of a paragraph here, and that is one thing that you consider in addition to the context. In fact, one thing leads to the other, to be honest here. So that's how it is. And to start off with building a DSL, you try to keep in mind that you have to satisfy these two characteristics. Okay. Two categories, quite simple: external and internal. The external is a whole new language that you create all by yourself. You're responsible for the compilation and parsing here, and you have like 100% flexibility here. And I kind of realized that SQL satisfies all these criteria here. So that's like I think probably one of the most expressive things that we've seen. So that is an example of external DSL. Whereas in internal, right, you tend to make use of what the language provides to you. So there's of course a limitation that the language is providing, right? So a great DSL would be the one where a great internal DSL would be the one where the language has very cool, amazing features to build your own independent language construct. Like it's not really restrictive. But by default, an internal DSL will have some limitations because the language does have some rules, because the language compiler is going to take care of the parsing, right? So so we'll look at what Kotlin has on the table for us. But yes, before that, I wanted you guys to look into these two very famous libraries that you guys might probably know. Starting off with Kotlin Anchor, right? That's a library which is designed to make the development faster for us. So, they've told that explicitly there, but then again, that's the target. If it's a DSL, you tend to understand it faster, you tend to develop faster, and people have understood it, and they are creating libraries to make life easy for us. And that is what our intention should be with respect to creating domain-specific languages. And you see here, this is a part of Kotlin Anchor. It's called Kotlin Anchor layouts. And their intention is to prevent us from writing XMLs. They take care of code generation. You just specify an expressive construct here, and they take care of the rest. That is about Kotlin Anchor. And this is, I think, even more famous library that Kotlin has for dependency injection. This is like pure Kotlin actually. So the way they talk about it is that it doesn't involve any code generation. That is, I guess, probably because whatever Dagger generates, these guys have purely implemented it using Kotlin features, Kotlin DSL, Kotlin functional constructs. So you see, these are the things that people are looking to solve. These are the domains that people are targeting to again make life easy. And I guess more or less we should tend to go towards the same, look into problems like these to again to make life easy for people like us. So let's start off with very, very simple Kotlin features. And well, the first point, I guess, might appear a bit lame considering that we've been Kotlin for quite a long time. But I thought that deserved mentioning because, again, with respect to a fluent something like you just read through a paragraph and stuff like that, when you see semicolon lying all over, that doesn't really help our cause, right? So in that aspect, the first point just deserves a bit of a mentioning here. And now we'll move on to the examples that I have to explain these features better. Okay, so we'll just start off with the infix here. So I just have a function, and that there is this infix keyword just behind it. And what it does to you is that, like originally you would end up calling this method using vehicle dot speed of whatever integer value, but you just end up removing those two. You don't need dot and you don't need circular brackets, and that is just one step towards some sort of a fluent language construct here. That is all there is to it. It's all a collection of Kotlin features that help us build really cool DSLs, and this is one step towards it. And yeah, that is basically all about infix. We'll talk about another common feature that we are aware of, extension functions. They allow us to define a function on top of a class without altering the code of that class. So one of the common extension functions that I've come across, I'm just finding the last character of a string here. This is the extension function that I've written. And so what Kotlin does is, what it resolves to is a static Java function actually, wherein that string would be the parameter for that function. Okay, so it's called a receiver. Anyway, I'll come about, explain about the receiver in a moment. But what it resolves to, again, is a static function with that string as a parameter. So what happens is, inside this function, we have access to all the public properties of the string. Here, for example, get and the length are public properties of a string. And that's why I'm able to access it. I'm able to find the last character. I just wrote one extension function, and I just called using the object of string. So that's about an extension function. Okay. Now we'll move towards lambdas, receivers, and higher order functions. And to start off with, just look at lambda as a block of code that starts with this curly bracket and ends with 1. That's about it. That's about what a lambda is here. Okay. But it serves some purpose here. In Kotlin, we have higher order functions which have parameters of function types. Okay, so I'll just move to an example to make it a bit clearer. So cool. So I have a higher order function here. Like I said, it is higher order function can have a function parameter or can even return a function. Well, in this example, it has a function parameter. Okay, the first parameter, which takes in 2 integers and returns an int. That's a function parameter, and thereby this function is higher order one. Cool. So when you call this, right, and that function parameter, you represent that function parameter using a block of code. And yes, that is what a lambda is, and that is the purpose of a lambda here. I'm just using this block of code, otherwise a lambda, to represent that function parameter. So you see this block of code takes in 2 integers, and I'm just returning, I'm performing something on top of it, and I'm returning it. That's it. But in essence, this block of code represents a function parameter here. Okay. So as far as Kotlin is concerned, putting the function parameter in the beginning and putting it in the end makes a bit of a difference with respect to representing the function call. Okay, and that is where my second function is about. That is what my second function is about. So if you see here, the only difference is that the parameter was the first parameter in the previous function, and here it's the end. But if you look at the call point, right, you just take this block of code, the lambda, and you remove it and you take it outside the circular brackets. And well, that is possible if your lambda is the last parameter in a function. So if my function parameter was the only parameter in that function, you won't even require the circular brackets. Okay, and you look at this, and doesn't it look similar to what you saw here, like a word and just a block of code? So this is to start off with building this kind of a language construct here. Okay, so that's about a lambda. That's about a lambda being the last parameter in a function. You just don't need to put the circular brackets at all. Okay, and well, now that kind of that is all a lambda is. That's all it is about. So we'll kind of talk about receivers now. So okay, a lambda is a block of code here, and when you're using Kotlin features, I mean, to develop cool language constructs, you will come across a lot of situations where the content inside a lambda would be suffering from some sort of an existential crisis. Okay, so they won't know who they belong to. The compiler won't know who they are. That's because they themselves don't know who they are. So you need to specify the lines inside a block of code with some sort of a context. You need someone external to that block of code to tell them that, hey, you belong to someone. You belong to a string. You belong to an intent. You belong to an activity. To let them know that, okay, fine, they are supposed to update the properties of string, activity, intent, respectively. Okay, so that is where a receiver comes in handy. Okay, so to just describe that with an example, let us look at the first function here. That is nothing, just a higher order function again, just like the previous examples, except this has only one function parameter here. And in the call side, like I said, we don't need the circular brackets. We just represent it using just one block of code. Okay, cool. That's just simple with respect to the previous example that I just described. Now, just for, again, to explain what a receiver is, to this block of code, I want to pass a string context. I want that block of code to know about a string, okay? And that is where a receiver comes in handy, and that is what the other function is. So I just wanted to pass what's up to this block of code. I just wanted to print what's up and with the name, okay? So what I did was I just took this function parameter. I just prefixed it using the receiver. This is all a receiver is, okay? And so when you call that function, you just call it using the string. In other words, you are passing a string context to this block of code, and that is all a receiver is. Talking about, I mean, if you guys are probably wondering, like, would there be a situation when I would need this, or would there be a situation when my block of code would require an external context? To answer that, we will come across an example. We will build something right now, and we will definitely come across a situation, okay? So that's about receivers. And just to again reiterate, you see A is the receiver here. For a moment, just remove A from the picture. It's just a lambda. It's just a function block which takes in a parameter of type B and returns C. Now, if this block of code has to know about an external context, if this block of code needs to know about A, that's how you do it. That's when a receiver comes in handy. Okay. So yeah, I think we've just discussed some stuffs here. Maybe it's probably a bit too much, but we'll start building something using these things, and things might become a bit clearer on the run. So yeah, cool then. Well, so I think it's a beautiful day today. So it's what, 25 November 2019, right? So it's just English that I wrote here, and it's possible to make it Kotlin, of course. And we were just talking about infix. We were just talking about extension functions a few minutes back. I'll use both of them, and it's possible to just resolve this to Kotlin. So first things first, I'll create a function called November, and I'm going to call that November using 25. So I'll create an extension function for an integer. Okay. So I'm going to go ahead with an extension function. Okay, I'm going to take a year parameter here, and it is an integer. Cool. Now I just put infix, and well, that is resolved. Okay. So I'm just going to return a Java local date. Okay. Then inside this, I compute. In fact, I have to return. I compute local date, and it requires a year parameter. I've received it as my parameter for this function, and then to calculate the month is November, and then the third parameter is the date of that month. Okay. So as far as an extension function is concerned, I'm calling this function November using 25. So inside this function, the context represents whatever you call it with. So this, in other words, this represents 25. So So that's basically it. I mean, what was some random language a minute back is now Kotlin by using these two features. Okay, so we'll just assign it to today. Okay, so what if I wanted to find 1 week from today? I mean, obviously I can find it, but I could represent it as. Would it be possible to represent it like this, like a fluent construct again? It totally is. I'm going to do the same, in fact, just to be more sure about this feature. So for the sake of this example, I'm going to define a variable called, and I'm going to keep it a long type actually. And I'll tell you why. Okay. So again, I'm going to define an infix extension function, and now I'm going to define an extension function for a long. I'm going to take a date parameter here. That will again compute 1 week from today and return a local date object. Okay. I just take that date, so return date and then plus days. And well, now plus days and 1 week is 7. The plus days function expects a long value, and that's the reason that I assigned long type to 1 week. Okay. So inside this extension function, the context represents whatever value you call it with. So I'm calling that function from using 1 week, right? So inside this would represent 1 week, which is 7, which I added to the date, and that's it done. So I have whatever is 1 week from today. Okay. In fact, you know what I did? I just maybe did some sort of an overkill here. Maybe this is not even necessary because, for example, if I want to calculate yesterday, I might as well just do today and just do minus. There's operator overloading in Kotlin. And well, that is just a method which expects a parameter of some type. So I would have to subtract it by using some parameter. Okay, this is just a parameter that a method expects that is not essential here. But the point here is that Kotlin also has operator overloading, which again is meant to make things easy for us, which again is meant to make the language more expressive for us. Okay, so if I look into this minus, it would result to another method of name minus in the class of type local date. Okay, so in other words, in Kotlin, a plus b would be represented as a dot plus of b. Okay, so you define a method called plus in your class, and that's it. You've done the operator overloading. That's as simple as that. Again, another feature that helps us in building a different language construct here. Okay, so I mean, yeah, I hope this example was pretty helpful in going with infix and extension function. You just could create as much as fluent constructs as you want using just these two features. Okay, to start off with. Okay, and I think I'll move on to a bit of Android here. Okay, so I mean, I've seen a lot of places, and I've seen a lot of times when we've written some code which we just keep repeating whatsoever. We don't really care, but I just wanted to have some fun with which would prevent me from writing these code over and over again. Otherwise you could probably call it boilerplate code, but it was more of me trying to have fun here. So I think we all know how an activity is launched in Android. Of course we know that. Well, instead of repeating this code over and over again, what if I could make it look more fun? What if I could make it look more expressive? In other words, what if I could make it look like this? Launch activity. 1 second. Launch activity with the name of the activity, and then just a block of code, and then well, that's it. What if is it possible to make it look like this? It totally is possible. But before making this work, I just again wanted to insist on the fact that this is more expressive, this is more friendly to us, and I think you would probably have fun developing constructs like this to prevent everyday code that you keep repeating over and over again. At least that is my intention, and that's why I proceeded towards having some fun with all the features that Kotlin provides. Okay, so let's move towards resolving this. Okay, so I have a function launch activity here. So you know what? I'll start with creating an extension function for an activity. Okay, we'll start with that, and of course we'll have to handle with we're gonna handle generics here. We're gonna handle with generics here. So we'll proceed with that first step. So an extension function for an activity. And well, as far as the parameter is concerned, what I see here is this function having one block of code as a parameter. Okay, so we'll create a block of code, and well, right now I don't really see it getting any parameters inside or returning anything. So I'll just define nothing. It just takes nothing inside and it takes unit. I mean, it returns unit. Okay. I mean, for now we'll just settle with this. I'll just put it on top so that I refer it and makes it easy for me. Cool. Now, yeah. So now we have a situation here. Now is the existential crisis that I was talking to you guys about earlier. We see these 3 lines inside the block of code, right? Put extra. They don't know who they belong to. That's what I was talking about. They need someone to tell from the outside that, hey, you guys belong to an intent. You guys are supposed to update the property of an intent. You guys are supposed to put extra onto the intent object. In other words, they require an intent context. So when this kind of a situation arises, that is where a receiver comes in handy. So to represent a receiver, you just prefix the receiver type and dot to the left of the lambda parameter there. Okay. We now understand that this block of code requires intent context. So I go ahead here and I mark intent as the receiver. And well, that's it. This now resolves. Now these 3 lines, they know they are now fine. They know who they belong to, right? So now that's about the receiver. That's the significance of receiver. You will surely come across a lot of situations like these, and it's pretty simple as far as this is concerned. Now the activity is obviously not going to start, so we'll have to inside this function create intent and start activity, right? So I'll go ahead with that. I'll just create an intent, and inside the context should be passed as this because that represents the activity which calls launch activity function, right? So I hope that's clear because it's an extension function, and inside an extension function, you have context to whoever calls you, okay? And now the activity name. Oh yeah, I haven't. I'm not handling generics yet. So I just put something over there, and then cool. I've created an intent object here. Well, we have some errors. We'll handle them in a moment. Now we have to update the properties of this intent. So whatever is inside that block of code, we'll have to make sure that this intent object is updated with those properties. Okay. In other words, you have to call that block of code using this intent object. Okay. Since this block of code has intent context, and you call that block of code using this intent object, its attributes will be updated. So in this line, as far as the third line is concerned, this intent has all of its attributes updated. It has all of its extras updated. Okay. Now you have the intent object ready, and you just start activity, and that's it. That's it. Your activity would start, except that it wouldn't because we have an error on top. This is with respect to a game that Kotlin plays when it comes to generics. Okay. So what it does is, if you come across the problem and you hover on top of it, it would tell something like reified. I don't know how to pronounce it, but well, reify. The meaning of the word is to make something real. Kotlin asks us to make this t real. It knows for sure that t at that point is not real, and it wants us to be sure of. It wants us to tell Kotlin that it wants from us that I need a real value of t. I can't manage with this. So what it asks us is to prefix reified, just telling Kotlin that, okay, fine, we'll make t real. But again, how? Again, even if I put reified over there, it would still throw an error here. It'll ask me to inline the function. And if I inline the function, it would be solved. I mean, I think we've basically solved the problem here. But what happens here? What happens here is that the function is inlined, okay? So it's an inline function, and we know what happens with respect to an inline function, right? The contents of the function is put into the point of call. But this is what Kotlin uses to solve the problem. This is what Kotlin uses to know who t is. So what it does is it takes the content of the function, puts it at the point of call, and at the point of call, you know who t is. and that's all Kotlin requires. And that is why Kotlin enforces us to follow these two sets of rules. And you know what Kotlin does? Kotlin, I've seen a lot of classes in Kotlin. They are basically wrappers over Java classes, which have a lot of methods which expect class type parameters. Okay, so what Kotlin does is they just write classes on top of these Java classes, and they just expect us to call these functions using the fancy language construct. They have written a lot of classes where they have a lot of inline functions and reified type parameters just to make life easy for us. And looking at that, I think we also can feel that we can also go ahead with this sort of approach to build really fancy language constructs and to make life easy for others. And that's about it actually. I think we start off with a whole lot of an error code, but of course an expressive code, and we just learned 2 features on the road. And every single feature I've discussed till now is probably enough to build lots and lots of fancy and really cool language constructs. Okay, so I think I have a good amount of time to discuss about the problem that I told you guys first, right? So I started off with this huge data class, and I told you guys that I made it look like something very small. So we'll just also take this time to discuss how I did it. Okay, so I went ahead with creating a builder here, okay, that has all the default values of whatever parameters your data class requires. And the build function gives me an immutable object of type UI state. Okay, so now let's build a proper function now. I'll just remove it. I'll just build from scratch. And usually when I go towards building DSLs, right, I just kind of write whatever I want, how I want it to look like, and then go forward and try to solve the problem. Okay, like speaking of which, this is what I want to achieve here. I want to achieve this language construct. So I'll go towards building one. Okay, so I'm going to create a function here, and again a block of code. I don't know what it takes in. I don't know what it returns. So to start off with, nothing. Okay. Now again comes the existential crisis that I was talking about. These 2 lines, they don't know who they belong to. And according to me, I know that they should belong to the builder because they should update the properties of a builder, and then that builder should give me the real object. Okay. So I'm going to use a receiver here. Receiver is going to come in handy here. So I just prefix it with that receiver, and this problem is solved, just like how we solved the previous problem. Okay, cool. Now inside this, it's my responsibility now to create an immutable object here. So what I do is I use the regular, I create a fresh builder here. Okay, and then now I have to update the properties of this builder. So whatever is in this block of code, my builder should know about it. My builder should be updated with these properties. In other words, I'll have to call that block of code using the builder. So now in the third line, this builder knows, this builder has updated itself with all these properties. Now you just call build and you're done. So yeah, I just have to return the object. And you're basically done here. And this is what this is all about. Except that, I would love to make this function look very short, really short, if possible, in a line. So maybe I'll try that out right now as well. And I'll just create another function now, UI, which is going to be just 1 line. Okay, it's going to expect the same parameter here. It's going to return a UI state also, except that I'm going to probably make it look in a single line. I'll probably have to remove this. Okay, so create an instance of the UI state builder, create an instance of the builder, and apply this instance to that block of code. See how Kotlin construct is basically. I mean, I'm just kind of talking when I'm writing something. Apply one of the standard functions in Kotlin, but I'll describe about it in a moment. But I just wrote something. I just talked about it, and probably you get the gist of it. apply the instance of the UI builder to this block of code, update the properties of the UI builder, and then just build, and you're done. So what was freelance is just a single line now. Okay, we'll now look into what an apply function is, of course. You look into the apply function. I mean, I've never done this, but okay. You look into the apply function, it expects a block of code with T as the receiver. That totally kind of satisfies our criteria. In our case, UI state builder is the receiver, which totally satisfies our criteria again. And the apply function again returns T. So in our case, that returns UI state builder. So after apply, you would get the updated UI state builder, and you just build, you get a UI state, and you're done. But the point here is that Kotlin internally has functions to make things look really meaningful and expressive for us. And on top of it, allows us to create more expressive language constructs for our friends and other developers. So, that's about it. That's about all the features, and that's about all the things that you can potentially do with Kotlin. Actually, I mean, I understand that I probably have taken a whole lot of features, but it's just you just look into it and you start building on your own. And I'm sure that you guys can build much better constructs than I just did. This is just to get all of us onboarded with and just go back home and just play around with the language. That's more about it. But I mean, to just finish it off, what we have a responsibility here. I mean, yes, we are having a lot of fun here, but we are having some sort of a responsibility here to create very easy APIs and to solve common problems and to always watch out for the everyday boilerplate code that we write repetitively, right? I mean, and then just make it look expressive, make it look more fun, and just have fun ourselves. And that's the whole idea about it. That's what I think Kotlin is making us do, and that kind of brings me to the end of it. And I really hope that you guys will play around with it and just share whatever you guys have created with us, and that should basically do it. So yeah, thanks guys, thanks for listening to me, and thank you.